In November 1986, Eric Graham released a demo for the Amiga called Juggler. When you open it, it has an intro screen that says, "The individual frames of the movie are being fetched from disk. The images were generated with a standard Amiga with 512 kilobytes of memory. A ray tracing method was used, which simulates rays of light reflecting within a mathematically defined scene. Each image requires the calculation of 64,000 light rays and takes approximately 1 hour to generate. An image is compressed to about 10 kilobytes for storage. Images are expanded in less than 30 milliseconds. The Amiga Hold and Modify mode is employed so that 4096 colors can be displayed at one time." Ostensibly, this doesn't really sound impressive. The effects here aren't being made in real time. Instead, the Juggler is basically a slideshow, a movie, with 24 unique pre-rendered images looping rapidly and with a sound effect. What's impressive about this demo instead are the balls. As you look at them, you can see mathematically accurate reflections of not only the surrounding landscape, but also the Juggler's body as well. In spite of being pre-rendered, this still was really eye-catching. It should be noted that in 1986, ray tracing was very much on the experimental edge of computing. Rendering a single ray-traced image would punish even the most high-end of computers. The most famous early ray tracing experiment was made in 1980 with this test image by Turner Whitted. This image was rendered on a DEC VAX 11780, a 32-bit Super Mini computer mainframe that would cost $1 million today, compared to the Amiga's price range of $3,500. With 8 megabytes of RAM, it took the VAX 74 minutes to render this. Only 6 years later, the Amiga could do the same thing, for a much cheaper price range, at half a megabyte of memory. Now that's Moore's Law in action. And also impressive is that the animation is capable of showing potentially all of the Amiga's palette, all 4096 colors. You might remember that last time I said the Amiga could only handle 32 colors per screen. So how did it do it? One neat trick with the Amiga is its so-called ham mode, which means hold and modify. Basically what it does is that the graphics chip uses 6 bits to assign a color to any pixel. Normally only 32 colors are used on a screen, and only 5 bits of that in any combination will be used to register to any of the pre-established 32 colors of the palette. But the ham mode does things differently. It takes away 1 bit, leaving 4, which can register only 16 colors for a screen palette. But the remaining 2 bits are used to issue a command change in any of the R, G, or B values of the previous pixel. It takes a look at the pixel to the left of it, and it says, "Okay, do that, but change the blue value to 15. The next pixel says, "Do that, but change the R value to 6. This mode leaves some serious graphic artifacts. It's never a smooth transition from one color to the other, but it works. And this mode was the mainstay for much of Amiga's artistic software, especially video editors. The ray tracing algorithm developed by Eric Graham was called SSG, that would eventually become Sculpt Animate 4D, a fully fledged 3D animation software. The Juggler demo was so iconic, and this guy appeared on everything from magazine covers to its own fan animations. It got so many people interested in 3D graphics, and the Amiga was where many of the long-lasting 3D tools we use today first began. Blender, Cinema 4D, and Lightwave all had their humble beginnings in the Commodore Amiga, and anybody who uses 3D software like this today is extending the long history of home computers being used to push the limits from the possible to the probable. Love and respect.